Hello everyone, this is Ray PCB, your trusted PCB partner. Today, we'll be introducing how to split power planes in KICD. Unlike other EDA tools, KICD does not distinguish between positive and negative signal layers. All power planes must be implemented using copper port. First, we can set up the power layer, although you can select the same layer class in the board settings. Let's take a look at that. In the board settings, here we can select the same layer class. For example, I can set the top and bottom layers as power layers. However, even if you select the power layer, apart from telling the router to ignore this layer during auto routing, it doesn't have any other practical effect. In KICD, there is no distinction between positive and negative signal layers. So when we want to create a power plane, we have to use copper port to divide it. Therefore, this setting is only useful during auto routing. When routing manually, it's actually of no use. However, in some other EDA tools, such as Ultimate Designer, the power layer is defined as a negative plane. That is, once you set it, the plane is automatically fully covered with copper by default. If there are areas on this plane where you don't want copper, you need to draw shapes on this layer, and then copper will be filled only within those shapes. When you place vias or pads, the tool will automatically clear space for them on the plane to prevent short circuits, unless they belong to the same net. This is quite different from how KiCad handles it. Creating a power plane is exactly the same as adding copper port on a signal layer. First, you need to set the power layer as the active layer. Then use the copper port command to draw a closed area. After completing the net and related settings, you can proceed with the fill. For example, earlier we set the bottom layer as the power layer, so let's make the bottom layer serve as select the bottom layer as the active layer for copper port. Next, we absolutely need to precisely locate the exact starting point, and once we successfully accomplish that, a comprehensive settings window will prominently pop up on your screen. We've already used this copper port settings window before, so just make some adjustments. First, let's make sure we're working on the bottom layer, and then we plan to pour. We just need to select the ground net as the base, then complete a closed area. Since we're doing a full board copper pour, I'll just draw along the edge of the PCB board, and that will be enough for the copper pour. For the last line, I won't draw it manually, I'll just let it close automatically. After drawing like this, KiCad doesn't fill it automatically, so we need to press B to let it fill. Now we can see the blue area, the entire blue area on the bottom layer is covered by the ground net, and it also connects the ground nets together. We can see that these ground nets are now connected. So we've completed the copper pour for one layer. There's also a simpler way. Since there's already a border layer, if you find tracing it just now a bit troublesome, you can use a slightly easier method, which is to draw a bigger rectangle. For example, I can just draw a large rectangle around the outside. You still need to select the correct net and layer, and then just draw it however you like. As long as it covers a larger area than the border, that's fine. This way, it's a bit quicker. Then press B to fill. It won't fill outside the board outline, it will only fill inside the board outline. This makes things a bit easier, so you don't have to precisely trace the 4 points. And if you need to split the power plane, for example, if both 5 volts at 3.3 V exists on the same layering, our case, let's take a look at the nets. We don't have 5 volts and 3.3 V. Instead, we have WCC and WCC-PIC as the 2 power nets. We'll use them as examples for splitting. To split them, you must perform the copper pour operation twice. In the copper port options, you can set the priority of the copper port. For overlapping areas, the priority determines which region gets copper poured. First, the higher the priority value, the higher the priority. Now, let's take a look at what priority means. First, we need to identify where the net we want to pour copper for is located. Let's find where WCC is. Here is a WCC network that we highlight. So we see that WCC is probably in this area, coming over this area, right? Then let's take a look again. WCC-PIC is in that area again. WCC-PIC is probably in this area. So we can cover copper first. Cover WCC first. Select copper pour. Then we click here, select the first inner layer, and then choose VCC. Here is a priority setting. If I want its priority to be lower, I set it to 0, making it the lowest priority. Then I roughly pour copper for the same net. And then move over this way. This side is larger, so I can be a bit more flexible. Inside the PCB, I need to be more precise. Now that VCC is done, let's pour copper for VCC PSA as well. Earlier, we saw that it's roughly this area, so we can actually have some overlapping region. Let's start from about here. We need to select the VCC PSA layer, set it as the default material, and then change the priority to 1. 1 is higher than 0, so it will have a higher priority. Let's see what having a higher priority looks like. We draw it across like this. Just draw across like this, then close it off. At this point, both have been assigned. Let's press B. Let's check the assignment effects. Because the VCC PSA net has a higher priority, even though WCC occupies this area, you can see that during the actual assignment process, this area is not assigned as WCC, but as VCC PSA. So when assigning, we need to set the priorities properly to make the assignment more reasonable. This way, areas with overlapping regions can be assigned more appropriately. Right now, it's definitely not reasonable because the WCC net hasn't been connected. There's also a way to convert a shape into an assignment region. If you use the assignment command directly, you have to manually draw a polygon, which makes it hard to quickly and accurately draw a shape, especially a rectangle. So there's a more convenient way. We can delete the underlying assignment. Let's delete it. Just like earlier, we drew a large rectangle, a large polygon, but we can also draw a rectangle since drawing a rectangle is much faster. For example, we can easily do this. First, draw a simple rectangle, then carefully select the appropriate tool. Next, precisely select the drawn rectangle, then right-click with your mouse, and right here you can conveniently convert it. You can convert it into an assignment region, which is a very useful feature. When converting, you still need to choose the layer, net, and priority. In this way, we've very simply drawn an assignment region, then press B to fill it, and you can see it still has the same effect. So when filling regular shapes like rectangles or circles, you can use these shortcut tools here. After drawing, just convert them. It's much more convenient than outlining a polygon directly. Alright, that's all for today's content. If you enjoyed this video, please subscribe to my channel for more videos. Thank you, everyone.